We are now just get started the final part, digital design presentation. At this time, we're going to make video file. Video for what? For design presentation, okay? So this video is totally different from your animation clip, which is taken by your smartphones or generated by your 3D Max or SketchUp, whatever it is. They are one of the resources for your final video, okay? Your video includes lots of things. Last semester, actually, you have learned how to generate series of images for making animation clip by using 3D Max, but we didn't take a look at some details for making finalized video file. So we are going to take a look at some series of applications. But actually, I put one more thing, okay? Another issue, digital design and fabrication. As you know, 3D printers, 2 3D printers are ready. So you're going to learn how to make your own physical markup model by using 3D printers in our lab, okay? Next week. So one part of next week issue is digital design and fabrication. Of course, others are video making technologies, lab exercises, okay? Also, we're gonna prep the final video-based presentation, okay? That's the plan as we planned. And actually, one more thing, mandatory class participation, guest lecturer's lecture regarding BIM-based interior architecture design, lecture by another professor from the US. Anyway, that's another special guest lecture, mandatorily participated. That's our plan. And let me briefly, actually not that brief, I put some details about your final project, okay? Common requirements here, and you can take a look at what to do. Most of you are involved in some design studio class, so your final design studio, even if it's not final, that's okay. I know your final design gonna be realized after the final. But anyway, even if some type of intermediate design presentation can be done by your video presentation in this class, okay? So take a look at those items in detail, okay? This slide. Anyway, due date is important, June 11th, noon, okay? Exactly before the class in 5th week, okay? Also, you have to log on to Google and upload on YouTube, okay? That's the requirement. Also, take a look at this description for your final project, okay? Here I list what to do today. You have already been done lab exercises, right? Including animation clips making, right? Shaders and animation making. This is the review from the last semester, actually. You know that. From next week, we're going to learn new type of applications, series of applications based upon this review, okay? Further development, further lab exercises. And as always, I put some techniques in modeling or rendering. Today's topic was mental ray shaders, renderers, okay? Something useful for your design representation. Also another one, BIM applications, demonstration after the lecture, okay? So let's quickly review digital design on class. You have learned some intro to design computing, intro to digital design, and CAD and graphics, okay, technically. So this class intended to show you and share some ideas about some advances in design computing, advances in digital design, okay? Digital design, CAD, design computing, computer-aided architectural design, no differences, okay? They are all the same terms. That's my point when you were freshmen. Anyway, let's quickly review some basics, some selective slides. This one is going to be useful for your prep, the midterm exam today, okay? After the class. Anyway, we are aiming to design, and there is something creation part. Something should be done by human brain, okay? But our topic is here, design authoring, development, visualization, analysis, and a lot of more things in the progress of design development, okay? We are using computers, computational process, okay? Some overlapped part is there, and at the end, anywhere on Earth, your building, your design, your interior, your object, your furniture possibly could be realized, okay? That's design. We are not doing some game design or some cyber design. We are some physical space designers, okay? Our goal design means design computing technologies, some overlapped part, some artificial intelligence area. This is very challenging research area, but we are partially deal with this part using very advanced technologies. Anyway, computer involves in this human creativity area. Even if we are not dealing with such advanced part, I think we have learned lots of small cases in the class or sometimes through the Facebook or the website and so on. Anyway, machine learning, AI, design, cognition, that's the overlapped part. Something needed to be discovered, okay? Need to be discovered, it's a challenging area. But in reality, we are mostly in this area, okay? Especially visualization. Your final visualized in series of images. In other words, represented in video. That's the topic, okay? Our process, simply say, to make a computational model. That's our class main objective, okay? How about your design studio course? Also, you are trying to make a computational model. The problem is that model is not final model. Always something iterative, update and changes, lots of errors, and dramatically changed by instructor's comment and so on, okay? Anyway, making a computational model is the process of our class. That model is supposed to be good one source, okay? And then we can extract entire structure we need, plans, drawings, video files, whatever, okay? So far, the most good one is, I think, building information modeling, okay? Simply say, Revit file. But actually, we have learned something like this for when we are learning 3D graphics. This is 2D, okay? It's not easy to recognize. That is why we draw lots of additional 2D drawings, but they are not 3D so far. Series of 2D images. Based upon those symbols, we imagine how it looks like in real world, in 3D, okay? That's the gap. 2D images and your imagination, possibly different. That's the problem, okay? That's why we need to generate 3D model. If possible, at the beginning of the design. So these are some perspective images, and that's why we invented, human invented 3D model, 3D representation. At first, they all surface-based model, SketchUp, 3D Max, Rhino, okay? But in Revit, Vasari, they are solid model. You know what's the difference, okay? So we have learned 2D drafting and 3D modeling. Why don't we get started your design process from 3D geometry, even in early phase of design? That's why you have learned SketchUp first before AutoCAD, okay? But anyway, for learning industry standard, we need to take a look at some CAD drawings, plans. But anyway, they are symbols, okay? We have to know symbols because they are something standardized way of communication in actual industry. That is why we have learned, but actually you already learned something more advanced one in terms of this CAD history, okay? Even if we are dealing with these two parts including this semester, total 3-4 classes, okay? But in this semester, we expanded our scope, learning scope, to the up-to-date, to the cutting-edge technologies in design computing by using BIM, okay? Application name, you remember that, right? Vasari and Revit, okay? That model includes entire formal technologies, okay? 3D Max or SketchUp easily extract 2D plans. Revit easily represent elevation, 3D views, plans, whatever, without any problem, okay? Simply because their connections are looking like this, okay? The subset of BIM is parametric model. Parametric model subset is solid model. Its subset is surface-based model. At the end, the small part is this kind of symbolized drawings. So in terms of this CAD history, SketchUp, AutoCAD, 3D Max, Rhino, whatever it is very advanced and beautifully generate 3D model, they are all in this category, okay? But Revit is totally different. You experienced, okay? Interface or its output files, interoperable issues, something very different. But anyway, simply, Revit is the most advanced one in this simple historical approaches, okay? So let's take a look at simple theory again. Actually, again and again. 3D geometric model based upon these sub-components because we are dealing with this geometry. Computer doesn't know this is a building mass or some object. This is just box-shaped geometry, group of polygons. That is why we have to control its sub-component, okay? But in BIM, Vasari, Revit, if computer knows this is building mass, in that case, we can separate levels. We can put some walls or building skin, and so on. Something advanced, totally based upon this building object, building element, building component. But this is conventional geometric modeling approach, good for visualization, not that good for building design, interior design, building skin design, whatever, okay? So in 3D modeler, there are primitives. We create those primitives at first stage and modify it until the geometry generated you want, okay? That's conventional process, very time consuming and some error prone. In that process, we draw some 2D section and extrude them for making 3D, very fundamental 3D object making. Simply this icon, okay? Push-pull. Lacing, we can simply revolve section profile so that we can generate very some imaginary structure, even in BIM tools, okay? Sweeping, also very, the follow me in SketchUp or definition of section and the paths, we can generate very imaginary 3D geometry object. Some others, skinning, Boolean operation, and so on. So this is the one way of we have learned or used in actual design objects, something like this, to edit this kind of structure. There is no cup or glass or some other object-specific things, only points and lines, okay? So Boolean operation is kind of interesting and very mathematical. Based upon those very simple equation, computer can calculate new type of geometry. This is fundamental approach. Based upon that, we can generate something like this mixed object. And last week, we generated some holes in anodized aluminum panel like object for making building surface. That's another way. Anyway, even this type of shape can be easily represented by this kind of equation. Okay, so as you see here, we have 5 different primitive objects, but at the end, this one can be generated based upon this equation. So this is one type of parametrics computers can recognize it, okay? So that computer generate this kind of geometry. Even in this stage, anyway, we should define in similar way so that computers can understand your design intent, okay? So actually, that is why we have to know and we have to think mathematically. In other words, computationally. Simply because you are not using pens or freehand sketch, okay? Now we are using computers. In that case, in that sense, we need to take more look about computers. This is the way how computer works, okay? Let's quickly look at another one, SketchUp. Actually, we didn't do any lab exercises in this semester for SketchUp. But for final project, making video clips, sometimes SketchUp-based modeling or video making is easier. So I'll let you know next week, okay? SketchUp and V-Ray, you can generate something from your SketchUp model easily for making animation clips. That is why I want to bring your attention again about SketchUp. 3D Max as well, surface 3D model, okay? This is surface model. This is solid model. But in actual application, such as 3D Max or SketchUp, when you cut it like this way, sometimes you may find out there are some solid-looking objects, but actually they are not solid. 3D Max or SketchUp automatically generate new face when you slice it. Sometimes not, okay? That is why you can find out sometimes this one is hollow inside or sometimes it's looking like solid. But anyway, they are all surface-based model. That is why some geometric errors or calculation problems in your solid model or some Boolean operation in 3D Max, SketchUp, whatever, okay? Very error prone. But in solid tool, no such problems. Everything is very clean because they are defined in solid. But behave like a solid object, but their original model or surface model. This gap sometimes makes some problems. That is why some errors you can encounter in this kind of operations in surface-based model. Anyway, surface model has edge, face, and points, okay? SketchUp intentionally dropped point control in its interface for making easier interface. That is why you can control face as the only, no point control without any plugins. But in 3D Max, you can control anything. In Rhino as well. So any type of complex building interior, exterior structures, they all the collection of face and edges, okay? That's fundamental theory of 3D graphics. And they all have segments. That is why you have to take care of number of segments in 3D Max, okay? Simply because lines are originally straight. Collection of straight lines make curve. And surface also, they have same mechanism. So this one shows you some same mechanism. And this one easily evaluated when we learned some building surface design using Vasari. Okay, curtain panel by using triangular shape or flat triangle or flat rectangle shape. Even if you draw something like this surface, anyway, panels loaded in flat form, okay, flat shape. As you know, V-Ray, very powerful renderer embedded in SketchUp as a plugin, so you can generate this kind of photorealistic renderings. And this semester final, you can use V-Ray. Sequence of this kind of images can be your animation clip. But as you know, it takes a really long time, okay? 30 images for 1 second. So if you need 10 seconds, it's not easy. 300 files in this quality, probably a couple of days. And also, in my description for the final project, your video file should be at least 1.5 minutes, okay? 2 minutes probably. So you need some set of animation clips from 3D Max or V-Ray. So need to be proactive for making animation clips. You can reuse 3D Warehouse, you know that, okay? So V-Ray renderer, totally same to mental ray, okay, in behind the technology, but different interface, okay? But similar terminology used in this kind of renderer, series of renderers. All these are some V-Ray specific things I prepared because we mostly use mental ray in actual lab exercise, but always I'm putting emphasis on they are all same anyway. Lighting source, target objects, camera, very easy. Sunlight or default light or mental ray sun, V-Ray sun, whatever. Amount of indirect illumination from artificial lights. And target objects, diffuse, reflection, refraction, caustics. And some texture maps for diffuse, bump maps, displacement maps, cutout maps, lots of texture maps on diffuse, reflection, refraction, and so on. You can apply such additional mapping options for making better visualization. So we need to know what is the intensity, how to assign texture map or color, and there is shadow casting, ambient occlusion, or some more even advanced features are there, okay? Similar terminology also applied in mental ray. Okay, I put this rendering overview diagram again. As you see, lighting, target object, observer. Observer means camera, okay? Your eyes. So they all have same structure, similar structure. So this one possibly one good source for running and using renderer. Under diffuse, intensity and color and texture map. That's all, okay? For calculating this kind of complicated equation by computers. Fortunately, we don't need to take care of this kind of equations simply because computers are in charge of doing this type of complicated calculation. What we need to do is take advantages of this kind of easy interface. That is why I'm always saying they are easy and some interface issues, okay? Originally, they are really complicated. But thanks to this kind of V-Ray, mental ray, or others, we can take advantages of photorealistic rendering effects. Reflection, the same. Some glossiness example files. It's actual visualization according to the numbers you put refraction, also different refraction effect based upon IOR. Self-illumination also has some variations like this. Not that complicated, just interface issues. Actually, the most important thing is global illumination, okay? So-called ray-traced rendering for making photorealistic rendering, okay? So this one simply shows you that kind of issue, ray-traced. This one doesn't trace this wall, okay? There is what? No ray-traced for this wall. Neglected this wall. But actually this wall has green color. So indirect illumination or global illumination, ray-traced effect applied, okay? That is why this one has some green colors. So this is better photorealistic render to this one. But this one reflects green color, but not globally illuminated or ray-traced. Advances in digital design. Actually, next week, I told you, digital design and fabrication is our topic for one part of our lecture and lab exercise. Next week, I'm going to let you print out some objects by using 3D printers, okay? Based upon your lab exercise models or whatever, okay? Simply say how to use 3D printers or how to use that plotter cutters or laser cutting or similar machines in terms of theory and actual application. But before doing that, this week, I like to show you some other issues, advances in digital design. Actually, so far, I mostly put emphasis on this kind of information, advanced information modeling issues regarding BIM, okay? Building information modeling or parametric modeling, they are something beyond CAD, something beyond 3D geometric modeling. So this kind of design alternative, and I believe now you can generate this kind of cotton panel system by using Revit or Vasari or any other similar tools. Your building mass and your surface building skin study by using your component, your part, okay? So that you can generate this kind of assembly. And this is actual case of that example. And this is, I told you, much advanced features and application we can do when you are learning and using this kind of advanced design computing tools, okay? Even more information, geospatial information. If you use geospatial information, in other words, if you use your site, specific site on our Earth, that means you can reuse additional data based upon that GIS data, okay? Such as weather data. This is wind rows, okay? Wind direction and wind speed. So if you get more information, the work, analysis, application you can do dramatically increased, okay? That's my point, and actually I need to demonstrate them, but anyway, today or next week. So I show you this quick example based upon Google Map. If you generate building mass, even in this kind of roughly generated, not that detailed, but that's okay. Even if you use this kind of model, they all have levels, and you can automatically slice them by the level. And if you click this building and create slabs, create walls, and then you can automatically generate walls, slabs, and so on. What's next? Open 12th floor and edit interior walls, finish, and doors, windows, and so on. And then you can finalize, I mean not that finalized one, actually make some progress in terms of that building design. So this one is the proof of that information handling, okay? Based upon this level slice. This is not geometric slice. This is spatial separation based on its level, okay? And then you can generate, this is the building name. Mass 2 is the building name in that design. And it has level 1 through 22, 22-story building. And each floor's area exactly, precisely calculated. Area is here. Exterior surface area and perimeter. Perimeter is the total length of perimeter lines. So precisely counted, even volume, that's okay. So this kind of additional information, if you want to use and if you need some more advanced applications, data, fundamental given and calculated data are available, ready for use, okay? They are waiting your usage, waiting your applications. So Windows analysis, I showed you this one before. By using additional application named Ecotech, I told you this is animation, not visualization. I'm going to demonstrate it, okay? This is the animation. If you place one single plane on these different levels, this kind of animated analysis, visualization can be generated. If you load SketchUp model, also you can do similar things by using that Ecotech wind tunnel analysis application, okay? I think most of you already got learned, involved in this special lecture last semester. Matthew Swartz from Georgia Tech, he introduced us this one as one of his research topics. But anyway, UAVs, somebody thinks this is not relevant to digital design, but actually, I told you our goal is to make computational model, okay, in 3D mostly, and we need to append information. But anyway, we need 3D geometry, 3D models, but this one will show you totally different way of, different approaches of computational model acquisition, okay, by using UAVs. UAV means unmanned aerial system, drones, okay? So this, not this kind of drones, okay? This kind of drones for commercial or actual research purpose use with this kind of GoPro or similar camera. By using this camera, we can take this picture, okay? Just even this kind of photography level, this one is looking really nice, okay? Because it's not easy to take picture in this height. But this UAV, this drone can do, okay? Animation, also same. This is Georgia Tech campus, Atlanta Midtown and Atlanta Downtown, US. So drone can rotating, and then so that taking this aerial panorama. What if you assign this image as your 3D Max background image? You can make any of your scene into this city, okay? This is some sphere-shaped aerial panorama, okay? The same image, actually. This is camera matching with 3D rendering. This is actual photo of the UAV taken, and this is your kind of new design or new plan. They can be easily placed. Actually, not just a simple Photoshop edit. This one can be done in real time. What I mean is, if this is animation, your building design can be loaded and it can be rotated. Even if your view changed or rotated, this building is going to be attached on this place, okay? By using some advanced geometric or some computational tools. So this is another 3D pictures. Actually, this kind of drone can take hundreds, thousands, even millions of really high resolution pictures, okay? So what we're gonna do by using these pictures. Just open one of the pictures and make some Photoshop edits, that's it. Or making animation. That's fundamental way of use, okay? There is the technology of photogrammetry, okay? Photogrammetry matching, I already showed you before using Autodesk 1-3D Sketch. If you take your friend's head 360 degree, and then you can make your friend's, how can I say, head. And next week, we're gonna print them out. We have laser scanner too for your head scan or object scan, interior scan, okay? Or your smartphone can take series of pictures and then convert that pictures into this kind of geometry, okay? This is primitive geometric creation using that image. Take a look at those points, okay? The points have some distance or location, some additional geometric information on top of this image. Huge data set. Based upon those images, computer can reorganize the structure of these pictures, okay? Like this way, some sparse point cloud and a little bit more dense point cloud. And then take a look at this one. This is actual viewpoint of the drone. But if you generate this image-based 3D geometry reconstruction, you can rotate your views, okay? This is not drone's view, okay? This is your rotating views based upon that geometry. They are all so far some point clouds, a little bit higher density. They can be transformed into this kind of mesh, okay? You know what is mesh? If you import SketchUp model into 3D Max, they are all editable mesh. And then you turn them into editable poly and edit geometry. But this one is, anyway, same mesh, but they have texture. Why they have texture? They all originally pictures, which means they have textures already, okay? Simply because they are all pictures. But actually, if you use laser scan, originally there are no such maps. But actually in laser scanner, they have digital camera too. Not only scanner, but also digital camera integrated. Digital camera take picture, laser scan get the distance, millions of points, photogrammetry. But actually, Google Earth or Google Map is kind of old technology, even if they are some type of advanced creators. 10 years ago, there is no such technology. So they spent amount of money for making Manhattan buildings. They made them by using SketchUp at that time, 10 years ago. I also involved in that project for getting small money, okay? SketchUp-based modeling. But nowadays, they can generate something similar geometry. But actually, they are not that precise so far. So they actually took pictures by using their automobile for Google Street View. But anyway, something blended way, aerial pictures and Street View pictures and some laser scan similar technologies and even more advanced technologies they use. And then they can create something. And human can modify geometry at the final stage so that they can create really sophisticated and good images of Google Earth. They take pictures and they attach building surface as a texture map, the same way of your 3D Max or SketchUp work. But this one is only one source that pictures photogrammetry. And this is no texture map mesh, triangle shaped mesh. And this is something high density map of point cloud. And this one shows you the location of drone and which point that drone took the picture, okay? I'm not sure the flight direction, but anyway, this one is its drone's movement path for taking hundreds of pictures to make that kind of images. Designed by computers anywhere, actually not only by computers. This is drone and camera, but somebody in the lab, research lab, like Matt, researched something like this, and someone tried to make some really highly advanced technologies in totally different department or area in computer science or some mathematics and so on. But we are in charge of designing buildings, interior, exterior, or furniture, whatever. We need to take advantages of such advanced tools, advanced techniques, mostly from computers, okay? So they are all some examples of computer-based design or some approaches, and even some VR or AR, augmented reality related design tools, or some new type of interface, and some cave, you know what's cave, some augmented reality and some virtual environment for design and so on. So we need to take a look at some advances in digital design. Next week, another one, fabrication. But actually today's main topic is video-based design presentation. Let's keep moving on for the rest of lab exercises, lectures. But actually today's lecture and lab exercise are some part of review, okay? You have learned last semester at the end, actually, but I would like to bring your attention again for video-based design presentation for your final project, okay? This is the design-based video-based presentation title page and some few more slides I prepared. But anyway, this is flipbook animation. So almost longer than 100 years ago, people invented this kind of animating method. Disney animation generated in that way. So lots of images can be taken by you or made by you, okay? This semester, application is going to be SketchUp or mostly, I think, 3D Max, okay? So actually in the course website, in our class website, I put this example page in the front page. Okay, actually, this is not accessible, I think. I'm gonna make some public page for you guys. This is not open access, but anyway, all they are some examples of final project videos, video files, okay? Probably you may know some of them because they uploaded all YouTube or Facebook. So all these examples probably useful for your final project development. So I like to share this video file later. But today, anyway, we need to review what's the important aspect, what's the important features you have to take care of, okay? Actually, there is no complicated or hard to understand technologies. I think very easy. Video is easy. Simply because it is this kind of flipbook animation, okay? The easiest way is drawing pictures, hundreds of pictures, and make this kind of flipbook. That could be your final project, okay? If you want to draw by hand, okay? Take pictures, your flipbook, and post it on YouTube or Facebook. That's okay. I saw you clicked like. Your friends something like this, right? I saw on Facebook, you clicked like, and on my timeline, I saw similar example, your friends walking around, right? That's another flip book. Anyway, easy to follow, okay? If you make video, you can bring real big attraction to your audiences, okay? That is why we need to make this kind of video in this 2015, okay? Usually you made design panel, series of panels, and some mock-up models. But nowadays, we have 3D printers, laser cutters, to make real mock-up models easily, quickly. But in reality, that's not true. But anyway, but we don't need to make some large-scale design panel. Simply generate design presentation video and post it on YouTube, Facebook, whatever, and play it by using your smartphone or tablet or PCs, whatever. And then that's going to be really attractive to your audiences. That's true, okay? So simple reason we have already why we need to make this kind of video-based design presentation. It is multimedia. You can put your text, your voice, your title, your background music, your instruments, whatever, okay? So I'm going to show you more examples next time, not live demo today. Let's take a look at general sequence. Firstly, you have to put your title, introduction, and you have to describe what is your concept. This is typical way. You don't need to follow this typical flow. It's up to you, okay? But I like to show you one of the typical approaches of video-based presentation. At the end, some ending credit, like Hollywood movies, your name, whatever. But actually, the most important part is the content, okay? Your design representation. In this part, if this is 2 minutes, probably this part going to be 1 minute or similar. So your 3D design representation, animation clips, your high resolution rendering image, whatever it is, 10, 20, 30 seconds your clips required, okay? That is why today, in today's lab exercise, we have reviewed how to make how to make animation clips in Max. That is why how you need to create this kind of JPEG sequence for better quality animation clip making, okay? That's the reason. So actually, I told you there are no advanced or hard to understand techniques in video making, but we need to know some technical aspects about video file formats and so on, okay? So here I list up how to make an animation video clips, animation clips for your design presentation by using those applications. We're going to use 3D Max, Photoshop, After Effects, Part Encoder, or some other tools. At the end, we're going to use very easy to use video making application, Power Director, or Premiere, whatever. Vega or some other tools are available. So this is the final editor for your video. At the end, you can export your video file in AVI, MOV, MP4, whatever. And then you can convert it again and again. So there is the codec. Codec means compressor, decompressor, okay? Not that hard, easy. Compressor, decompressor, simply because thousands of images you have to see, you have to watch, and that's the video file. It's not easy, okay? That is why we need to compress file size, and then we need to decompress it when you watch the video. So simply because of that kind of heavy load, we need to use that kind of codec. I recommend you to use MP4 file as always, okay, at the end. So this graph simply shows you the comparison between uncompressed and compressed file size. And here also I list up some video file format basics. Your final project recommended to export it in this HD, okay? My recommendation. Even if your animation clip is lower resolution, that's okay. Anyway, this is your final video file size recommended. FPS 30 is kind of recommended, but 25 is okay. And MP4 file. Audio format, audio sound, something good sound quality required. Okay. Bitrate 128. So authoring a video file, here I also list up some technical aspects when you are dealing with video files. From next week, we're going to deal with this one actually in lab exercise and lecture series for the preparation of your final project. I like to see you one by one for your topic issues. And next week's assignment is going to be making your storyboard for the final, okay? Actually, we have 3 more weeks for the final. So we don't have not that much time. So we need to keep moving on. Anyway, some technical aspects I described. And this is the most frequently used tool, converter, okay? Your video file format from AVI to MP4, whatever possible. So this kind of tool required. And this is Camtasia video. You can record your computer screen. Actually, I put requirements here. Your final could be one of them, presenting your design studio work. That's recommended one, okay? Second one is your design portfolio video. Whatever you designed before, not in this semester, when you were freshman, whatever it is, that's okay. Describing you, anyway, that's okay, okay? The last one is some design competition preparation. Among 2 and 3, you can put how to make something by using specific application you have learned in this semester or last semester. So in that case, you need to record your computer screen, higher resolution. In that case, you can use that kind of application, okay? Camtasia video. This kind of application, Camtasia. And next week, we will use After Effects. Today, you generated sequential JPEG files, okay? So if you import that sequence of JPEG files, you can easily export this sequence JPEG files into one single video format, okay? One integrated video file with good quality. But actually, there are more utilities, free utilities to convert JPEG sequences into video file. But anyway, this one we're going to use. And then you can bring this on your workspace and bring your image file, your audio file. This is really Photoshop-like application. The same layer, effect, and interface. So next week in the lab exercise, we're going to learn how to make compositional video file. You're going to bring your file, your image, and you're going to make a blended composition animation by using this After Effects. Or actually, there are amount of more advanced video editing techniques embedded in After Effects, but we're going to use some part of, very tiny part of After Effects. This is one type of professional video editing software named Premiere, Adobe Premiere. We can use this one, but I like to use something different one, such as Power Director, or this is Flash. This is very good for web publication. On the website, there are amount of Flash movies, and this one and this kind of Power Director or even Premiere, they are looking totally different, but same mechanism, same structure. There is timeline, work window, and library window, okay? Take a look at this one. This is your timeline, okay? Timeline means 0 second to 40 second. You can place your video, your text, your another video, your own text, and transition effect, and music, okay? Your music file, your sound. You can control anything in this timeline. For making this video, you need amount of your component, okay? Your text, your script, your voice, your music, your animation clip, and so on. They are in your library, okay? They're gonna be loaded into your timeline. And you can preview in Workspace and export that. Very simple mechanism. Here, library window, movie clips from your smartphone. You can take your picture, your selfie in animation, in movie format, and you can put it. It doesn't matter, okay? Audio, background music, and 3D Max animation clip, SketchUp animation clip, your screenshot video file, whatever, they are all loaded into your library. And timeline window, you can control time. And you need to edit, preview, export. Very straightforward and intuitive. We're going to deal with this one actually next week. But at the end, there is no complicated technologies, no complicated skills required. Content is matter, as always, okay? This is your storyboard, okay? Not today's assignment. What I mean is next week's assignment. So after next week, you have to bring your storyboard for your final project, okay? I'll let you know about this one next week too. Anyway, you don't need to draw some detailed drawings. At least you simply sketch and simply describe your process, flow of your video-based presentation regarding your design, okay? That's my intent for this storyboard. But actually, at the end, if you load your content on the timeline, this is actual your storyboard, okay? You can take a look at in 40 seconds, there is 3D Max animation and some specific text callouts. The sequence of this one is going to be actual your storyboard anyway. Before making this physical, actual timeline edit, I like to encourage you to make handmade storyboard first, okay? Okay, that's it for today's lecture. Let's move on to the rest of the lab exercise and the exam quickly after the break, okay?